So today we will learn how to come up with the graphs of trigonometric functions. So the graph of sine theta, cos theta, and tan theta. So let's understand how sine x changes when we give it different values of x. What is the pattern? Will it increase? Will it decrease? Or will it increase or decrease? What will happen?
So every 90 degrees, it'll reach its peak, which is 1.
Yeah,
And
very good.
then it'll go back down and then go back up.
But why is that? Why is that happening?
Because it's a circle and it's reaching the topmost part is the peak. So
Yeah,
from 0 to 90, it's increasing. Then it hits its peak. Then it goes down until it hits its
becomes
negative.
negative.
Yeah.
So at 90, it is positive 1. 0, it is 0. And at 180,
0.
180 again 0. And then it will increase on the negative side.
So negative 1.
Negative 1, 0, 0. And then it will start reducing on the negative side. And it again becomes 0 on 360. And why is it happening? Because sine is the y coordinate. Sine is the y coordinate, and the length of the y coordinate is increasing, and then reducing. So we draw this on a graph. This is pi by 2, which is 90. This is 2 pi, which is 180. Then
Isn't just pi, isn't pi 180?
yes, pi 180. Then 3 pi by 2. And then 2 pi. Now it is 1, the maximum value is 1, and the minimum value is -1.
Negative 1.
So it will increase till 1, then decrease, then again decrease, it will become -1, and then come back to 0 at 2 pi. And this, the one complete circle is done. Now this will continue, right? What will be the next value? 5 pi by
So
3 pi, 7 pi by, and then
4
2
pi.
complete circles is 4 pi. It will again go like this, come down, and this will also happen on the negative side as well. Similar behavior. So this is pi, negative pi by 2, and negative pi will go at the bottom, and it will again come back to 0 at pi. And from here we can observe that sine of theta is 0 at integral multiples of pi, multiples of 180. Right, here it is 0, here it is 0, here it is 0, here it is 0, and on the negative side also. Right, so this completes the graph of sine. What are the characteristics here? Some observations.
It's repeating infinitely.
Very good. And what is that technically known as?
Periodic function.
Periodicity. Yes. So first characteristic is that the function is periodic. Second characteristic is, what is the period value? After what time it repeats?
Every 2 pi
2
radians
pi. 2 pi radians or 360
degrees.
degrees. That is why this is also known as a circular function or the periodic function. That is why the name is circular function or periodic function. Third observation. What is the maximum or the minimum value?
1 and -1.
1 and negative. Fourth characteristic. Sine theta is 0 when theta is n pi. Fifth characteristics. Sine theta is 1 when theta is
Uh, every pi. I mean
or
every
minus 1 or minus 1 at every odd multiple of pi by 2, isn't it?
yeah.
Odd multiple. It could be 1 or it could be minus 1. So at pi by 2 it is 1, the next odd is 3, it is minus 1, the next odd is 5, it is positive, and then it is negative. And sixth, it passes through origin. So from this, we can see what will be its domain and range. Now let's recall what is the domain of a function.
Every x value, every input.
Yes, for whatever values of x the function is defined, and we are seeing that it can take any value at any value of x. So domain is x belongs to
Infinity.
any real number. The function is y is equals to sine x. Right? This is our y-axis. This is our x-axis. So the domain is real numbers, but what is the range?
-1 to 1.
Negative 1 to 1. And how do you write that in the interval form? X
Negative
belongs
1.
to
Oh, I don't know this form. I know the -1 is uh less than or equal to x is less than or equal to 1.
very good. The way I have written this is known as the interval notation. This is also used in textbooks. It's very simple to read. -1, comma 1, the lower bound and the upper bound written in square brackets. And why are we writing square brackets? Because we know that 1 and -1, the boundary values are included in the range. If they were not included, then we would have written x belongs to open bracket -1. Simply the parenthesis, the round brackets. This means -1 and 1 are not in the set, not included in the range. And what does this symbol means?
Uh,
This means belongs to. When you will study sets, you will become familiar with this terminology. So this completes our sine function. Now let's come to cosine. Any doubts in this?
no.
Okay. Next is our cosine function. If I draw a unit circle and try to see as theta increases, as x increases, what
So
happens to
x
the
x starts at its peak at 0, and then
at
it gradually gets smaller until it reaches -1 or 180 degrees. That's its minimum.
yes.
And then after it
No, no,
hits
minimum,
1,
okay. But it will also become zero at
90.
90, and then it will start reducing or increasing on the negative side and become -1.
Yeah,
Very
yeah.
good. So if I draw an axis like this, what will be the value at 0? Theta 0.
0 degree. It'll be 1.
1. We're starting from 1 because cos x is the horizontal coordinate. So we're starting from 1. As we go to pi by 2, the value will become 0. So it will reduce from 1 to 0. And as we move further in the second quadrant, from pi by 2 to pi, it will increase but on the negative side. And then from third quadrant, pi to 3 pi by 2,
It'll go back to 0.
it will go back to 0. It will increase to 0 from -1 to 0. This is -1. And then 3 pi by 2 to pi. It will again become positive and it will increase to 1. And then this behavior will continue. So after pi, I will have 5 pi by 2. Then I will have 7 pi by 2. No, I will have 4 pi. No, this is 2 pi, 3 pi, and then 7 pi by 2, and then 4 pi. So let's draw the exact same graph. And the same behavior will continue on the left. Negative pi by 2, negative pi. What will be here? After negative pi, it will be negative 3 pi by 2. It will be 0 again. And it will continue like this. So what is the domain and what is the range?
Same as last time with sine.
Yes, very good. Same as sine graph. X belongs to R is the domain, and X belongs to -1 to 1. And how does it differ from sine in terms of its characteristics?
It starts at its maximum value, and then it every 180 degrees it hits its minimum or maximum.
Yeah. So it is also periodic,
Yeah,
and its period is
2 pi again.
yeah again 2 pi. Its maximum and minimum are 1 and -1,
Yeah,
and when it is 0, every odd multiple of pi by 2. 2n plus 1 times pi by 2. And fifth, it doesn't pass through origin, not passes through origin. And domain and range we have already written. Next is y is equals to tan x. Now, how do we find out the behavior of tan x? For that, we would need to write some values 0, 30, 45, 60, and 90. What is tan x? The ratio of sine
It's
over cos. From the
yeah.
table we learned, what will be that?
For 90, it's undefined.
It is infinity, right? Not defined. And for 0,
Oh, it's just 0, I think.
0, because the sine is 0. So tan x is actually sine over cos. So if the numerator is 0, it doesn't matter what the denominator is. So tan 0 is 0. Tan 30,
Uh, uh, 2 root 3 over 3.
root 3 over 3, which is 1 over root 3. Or we can also write root 3 over 3, which is approximately 0.5. Approximately 0.5 to one decimal place.
Yeah.
Then tan pi by 4,
Just 1.
just 1. Tan 60, tan pi by 3,
Um, 3,
root 3.
root 3. Yeah.
And the value of root 3 is approximately 1.7,
1.7.
right? So we are observing that it is increasing from 0 to infinity, right? After, see, till 60 it is very slow. Till 60 degrees it is very slow. It is 0, 0.5, 1 and 1.7. And then in the range of only 30 degrees, next 30 degrees it shoots to infinity, right? So if I want to draw the graph of tan x in the first quadrant, 0 and pi by 2. This is the first quadrant. From 0 it will start and it will increase somewhere here, which is pi by 6, sorry, pi by 3, which is 60 degrees, it will become equal to root 3, right? Somewhere
Mm-hmm.
midway, pi by 4, it will be 1, right? And after that, we don't know what the values are, but we know that it has to increase because it has to go to infinity. So it will increase like this. And it will become this line, this vertical line, it will touch this line
The
at infinity.
asymptote, right?
Asymptote, very good. So such lines are known as asymptotes. What is the actual definition of an asymptote? The line
It's like the boundary line where the function will never cross it. Like,
will cross. The line will become a tangent. Line will be that line which touches the graph at infinity. The graph touches the line or the line touches the graph only at infinity, at larger values of y or x, right? This is a vertical asymptote, so to say. In this case, we are seeing it is a vertical asymptote. We will also come across functions where there are horizontal asymptotes. where x becomes infinity and then the function touches. Here y is becoming infinity, right? So we have gotten the graph of the function in the first quadrant. And when you move the same behavior on the second quadrant, you will observe that the graph will show the same behavior but on the negative side. So this will become another asymptote, right? So what I've done, this is actually the fourth quadrant, isn't it? The first quadrant is from 0 to pi by 2. The fourth quadrant is the negative angle. We can also consider the negative angle, 0 to negative pi by 2. So if you think about it, here tan was sine over cos, and both were positive. So the ratio is also positive, right? But if you change the angle to negative, the ratio is still sine over cos, but which sign has changed? The sine one or the cos one? Cos
True.
is cos is positive because the x coordinate always remains positive, but the y coordinate becomes negative for these values of angle, right? So
Yeah.
positive upon negative will give you negative. So the magnitude of the ratio is the same. Both numbers are same, sine over cos, sine over cos. Whatever ratio, let's consider one point here. Let's consider this and then exactly same angle at the bottom. These two triangles are congruent, right? Whatever is cos, the base is same and the perpendicular have the different sign, right? So sorry, the cos is positive and sine is negative. This makes more sense, right? The base is the same, but the opposite have changed signs and it is equal in magnitude. So that is why we will get exactly same answers for negative angles, but with an opposite sign. So if I have here an angle negative pi by 3, what will be its value? Negative root 3. If I have an angle here, which is negative pi by 4, what will be its value?
-1.
Negative 1, right? So this is the
Mhm.
behavior in between minus pi by 2 and pi by 2. And this behavior will replicate itself. So if I go to now the second quadrant, which is from pi by 2 to pi, right? We know that uh, wait, pi should be double of pi by 2. So this is pi. Now we know that at pi, sine is 0, isn't it? Because sine was 0 when? Let's go back to the sine curve. When was sine 0?
Uh, every
No,
180 degrees starting
every,
from
yeah,
0.
multiple of pi, right? So there is one pi here. So sine will be 0 and what will be cos pi here? Cos pi is negative 1 from the above graph. Cos pi was negative 1,
Hmm.
right? So what will be the ratio? The numerator is 0. So whenever sine pi is 0, tan pi will also be 0,
Yeah.
right? So that means each of these graphs replicas will always pass through pi, 2 pi, 3 pi. They will always pass through here, right? And what is the sign of tan theta in the second quadrant? This is the first quadrant. Now we are going to the second quadrant. Second quadrant, what was the sign? Negative or positive? Add sugar to
Negative.
coffee. Negative. So it will be like this. Right? And then in the third quadrant, from pi to 2 pi to 3 pi by 2. 3 pi by 2 it will be
Uh,
pi to 3 pi by 2.
this.
Third quadrant.
Uh, it would be positive.
Positive. And we know that at 3 pi by 2, cos is 0. Now the cos will become 0 at 3 pi by 2. Because we deduced earlier that cos is 0 at every odd multiple of pi by 2. Right? So it means 3 pi by 2 will be another asymptote. Right? 3 pi by 2, cos 3 pi by 2 becomes 0. Whatever sign 3 pi by 2 is, we don't need to even worry about it, because something upon 0 is infinity. So that means tan 3 pi by 2 is also infinity, because the denominator becomes 0 at every odd multiple of pi by 2. So we can draw a vertical line again at 3 pi by 2. And it will show the same behavior like this. It will touch 3 pi by 2 at infinity. Now next asymptote will be 5 pi by 2.
Yeah.
Right? And let's draw the asymptote. And 2 pi, it will be 0. Between 3 pi by 2 pi, it has to be negative, because it is the fourth quadrant. And this behavior will continue. The graphs are like this, where these are the asymptotes. Now what will be this angle? This will be a multiple of pi, right? And this will be negative pi. This will be negative 2 pi. And this vertical line will be
Negative 3 pi over 2.
negative 3 pi over. So it has a lot of vertical asymptotes. So let's write that. First characteristic is its vertical asymptotes are the lines x is equals to 2n plus 1 pi, odd multiples of pi by 2. Second characteristics, tan theta is 0 for every multiple of 180. Theta is equals to n pi. This is very easy to deduce, because sine is 0 here. Therefore, tan theta will also become 0. And this one, cos theta is 0 for every odd multiple of pi by 2. So tan theta will become infinity in such cases. And the third characteristic is the function is discontinuous. It has breaks. We cannot draw the graph of the function without lifting our pencil. Right? It was not the case with sine and cos. Right? And the fourth characteristic is it passes through origin. And out of the three curves, sine, cos, and tan, can you tell me which of the three is symmetric along the y-axis?
Um,
Which of the three is symmetric along the y-axis? You understand the meaning of the word symmetric?
yeah, I think it's the cosine one.
Cosine, yeah. If let's say what does symmetric mean? If let's say the y-axis is the mirror line, you will get a mirror image,
Yeah.
right? The mirror image. So cosine is symmetric. And one last thing, what is the domain and range of tan x?
Um, I think both are infinity,
No.
but it can't be the every 90 degrees or every from starting from 90 every 180.
What is that?
So it can be any x value except for the asymptotes.
Yes, any x value except the asymptote. So how do we write that? R is the all real numbers minus odd multiples of 2n plus 1 times pi by 2. This is the way to write it. This is the domain. X belongs to which set? Real numbers, all real numbers except odd multiples of pi by 2, because these numbers make tan infinity, right? And for domain, we exclude those values which make the function infinity, which make the function not defined. That is the definition of domain. And what is range? Are there any values of y which can never happen? But everything
Um,
in y can happen.
yeah.
Everything in y can happen, right? It can take any value from negative infinity to positive infinity. So the entire lumber line is the range. We can also write it as y is less than infinity and greater than or equal to negative infinity. And we can also write this in the form of sets. We can write it as y belongs to open brackets negative infinity to infinity. Why have we chosen open interval here? Because infinity you can never reach. If you write this as minus infinity to infinity closed brackets, this would have been a wrong statement, right? This is incorrect. Infinity is never reachable, so we should always write round brackets. So this
And you're muted.